A single deleted row in a financial model should not bring down an entire corporate reporting pipeline. But when workbooks are linked across departments, one missing baseline reference can trigger a cascade of failures through every connected node. Enterprise teams rely heavily on multi-departmental pipelines. Finance calculates the costs, sales pulls those costs to determine margins, and operations ingest the sales data to build executive dashboards. The core infrastructure vulnerability holding this entire structure together is the cross-workbook external link. If an analyst in finance deletes a working column, Excel generates a #ref error. When sales and operations pull from that file, the error travels across the network boundary, mutating into a #value error as it reaches its final destination. By the time that failure surfaces in operations, the underlying structural context of that error is completely lost. The downstream operator is left staring at a broken dashboard without knowing if the issue is a math anomaly, a missing lookup, or a deleted source sheet, doubling the time it takes to debug the system. To clean up the visual interface, many professionals wrap their formulas in an if-error function to replace those ugly dashboard warnings with blanks or zeros. But passive suppression creates silent structural failures. It treats a structural breach in the data model exactly the same as a simple missing ledger entry, hiding the true state of the data from the user. Raw Excel errors must never be exported across a network link. To build resilient corporate pipelines, we have to isolate those breaks at the source, using an active, self-diagnosing edge defensive architecture. The first step in building this architecture is diagnosing system exceptions exactly where they occur, at the cell level. Microsoft Excel and Google Sheets share a native diagnostic engine for this called the ERROR.TYPE function. This function evaluates a broken cell and translates the specific failure into a standardized integer between 1 and 8. A mathematical anomaly, like dividing by 0, returns the integer 2. A simple missing data lookup, like an unmatched VLOOKUP returning NA, outputs a 7. Once we extract that raw system integer, we map it to a global data catalog. Every department in the pipeline references the exact same centralized remediation lookup table. This acts as our diagnostic dictionary. By nesting the ERROR.TYPE function inside an XLOOKUP, the spreadsheet automatically translates the raw engine exception into localized remediation scripts. If the system detects an error code 4, it instantly prints instructions directly inside the user's view, telling them to contact the finance workbook owner. Pairing this diagnostic engine with a structured remediation table shifts the workbook from a passive data grid into an active application that diagnoses its own exceptions. To enforce this logic across departments, we establish a physical architectural boundary known as the export layer. The strict structural rule for this architecture is that a source workbook must isolate its raw calculation tabs. Downstream departments are forbidden from pointing external links directly to working data cells. Instead, we build a dedicated export sheet. This new export tab contains 3 core components: a dedicated data column, a standardized status code column, and a detailed user help column. The formulas inside this layer evaluate the raw source cells locally within the finance environment. If a structural error is detected, the layer prevents the live engine crash from passing through, converting it into a clean, text-based operational status code. Wrapping this evaluation step inside a let function forces Excel to cache the heavy external connection exactly once, stopping network lag from paralyzing the workbook. When it is time for downstream ingestion, the sales workbook points its external references exclusively to this firewall layer. The receiving workbook now imports a stable text string rather than a volatile live error component. Because that imported flag is standard text, the sales workbook can easily run local conditional logic to manage the anomaly. An if statement checks the incoming text. If the flag does not read status OK, sales halts its own margin calculations for that specific row. Sales then passes its own localized status message, flagging the row as blocked by finance, downstream to the operations node. Isolating raw working data behind these edge defensive export layers ensures downstream connections only carry controlled operational flags, catching cascading failures at their point of origin. Evaluating the newly engineered data flow across the multi-department pipeline, we see a stabilized network. Consider what happens now if a sudden baseline structure deletion occurs in the finance node. The edge defensive architecture responds instantly. The red error halts at the boundary. Clean yellow text reading ERR-4-ref travels to sales, and blocked by finance travels to operations without mutating the context. Because of these clean status messages, the downstream dashboards safely pause calculations before any corrupted arrays reach executives. This yields a documented 30% reduction in debugging time. Operations operators are directly instructed to contact the specific finance admin to restore the source column, eliminating all guesswork. However, external links remain vulnerable to connection state errors. If a source file is closed or moving in a cloud directory, the connection can throw false reference exceptions. The next step in enterprise architecture modernization is replacing legacy cell-to-cell formulas entirely with Power Query. Power Query handles cross-workbook transfers securely by inherently isolating anomalous row-level errors from the wider master calculation, preventing the entire file from crashing over a single failure. It also allows custom metadata tagging during the import process, allowing architects to append the origin department's name to any broken row for instant diagnostics. Whether using boundary-level ERROR.TYPE formula logic or modern Power Query audit flows, building a self-healing spreadsheet requires a shift from passive error suppression to proactive structural isolation.